All right, students, we are hitting 6.4 with proportional reasoning. I'm doing the homework portion right now. So I did skip a few. I skipped 3, 6, 10, 13, 14, and then a chunk between 15 and 20. So as you're looking, remember, these are basically chances to work on both ratios and solving equations. So when you kind of look at this, kind of take your time, work through them, but I'm giving you a few that kind of start small. Determine the ratio of vowels, vowels to consonants, the ratio of consonants to vowels, and the ratio of consonants to letters. So again, if you had vowels to consonants, if it was 2 for every 3, then if you went the other direction, it would be 3 for every 2. And then consonants total would be 3 for every 5 because there's 2 of one and 3 of another. That gives you 5 in every group. That also tells you something, right? If you know how many consonants, how many vowels there are, you know that ratio, you know the total number must be a multiple of 5, because again, 2 to 3 gets you 5 total. Next chunk is solving for x. I do not care how you do it. I have given a few really quick tips. I hope they're helpful. Totally up to you though. So if you wanted to, you could do the switcheroo pieces. You could do the multiplication pieces. Like in B, you could just multiply both sides by a single number, could get there. Any way you want to do it is just fine, as long as it's one of the legal methods. Let's see here. This is 5 adults to each teenager. This many adults, how many teenagers? Again, set up the ratios. Set it up and put an equal sign between them to form a proportion. The candle is 30 inches long. After burning for 12 minutes, it's this long. All right, so now you know something, right? Now you know 12 minutes takes away 5 inches on a candle. So 12 minutes to 5 inches. How long will it take for the whole candle to burn? The whole candle was 30 inches. Think about your ratios. Okay. Same. Again, all these are roughly the same. The student to teacher ratio is 1 to 30. Again, that's a good thing to think about if you're going to be a future teacher. So 1 teacher for every 30 students. Now it tells you how many students they have. So you could pause there and figure out how many teachers. And then it says how many additional teachers must be hired if they want to change the ratio to 1 teacher for every 20 students, which is much better, especially for those of you who are going into kind of younger grades. Having 30, 35 students in a class is problematic. There's a whole lot more with classroom management than teaching. And once they get too many kids in a class, it almost becomes more like just a huge babysitting exercise. That doesn't make it good if you want to actually be a teacher. All right. Well, let's see. What else do we have? Ratios, feet to length. Find 3 sets of X and Y values that would make this true. Again, 4 tickets for 20 bucks. How many tickets for how much money could you make it so that they are actually proportionate? Rent is $8.50 for 2 weeks. How much is rent for 7 weeks? There you go. So again, proportional reasoning. Yep. You probably do this more often than you think. Look at this one, number 15. Here's how many miles I can go on 15 gallons of gas. How far can I go if I just have 3 gallons of gas? Okay, there's ratios. Put them into an equal sign to find the missing piece. You've got a proportion. What else do I have? A certain recipe takes this much flour and this much milk. How much milk should be used if I only have 1 cup of flour? Ooh, scaling down, creating a nice proportion there. So if you've never done this, it's because maybe you always have enough of all the ingredients. Sometimes I'll look in the fridge and I'll be like, okay, the recipe calls for 3 eggs, but I have 2 eggs. I guess we're making a smaller batch. And as long as you kind of take everything down in proportion, you're going to be pretty close. It's a fantastic one here with scientists. They really do this. This is an actual technique. You estimate how many fish are in a lake. They go out and they capture a bunch of fish. They catch them and they put a little tag on them and then they dump them right back in the water. Then they go back and they catch a bunch of fish again and they see how many of those fish are tagged. And so you create 2 ratios, one with total number of fish and one with the fish in my sample. And so you can actually go back and estimate about how many fish are in the lake without really knowing. exactly how many fish are in the lake. Let's see here. Okay, yeah, all of these are, I don't know. I mean, basically all of these are the same type of question. Let's see if there's some in here. So I said 15, 16, 17, 18. Okay, so 16, 17, 18, those aren't ones that I assigned. 17, 18. Okay, why don't I'll kind of demonstrate here the idea on a problem that really wasn't listed there. Okay. The ratio of the length of a flag to its width must be 19 to 10. Okay, that's an American flag. So that means length to width has to be 19 to 10. Okay, so it's longer than it is wide. Okay. If a flag is to be 9.5 feet long, how wide should it be? Okay, so if I put up here 9.5 feet long, okay, then how wide should it be? And I'd put an X down here, or a W maybe for the width. Now you can solve this in many ways. Okay, I've given you a couple that we could try. You could switch two of the numbers. You could flip both of them over if you prefer to have the W on top and then just multiply by a single number. That's up to you. But when you start mixing whole numbers with fractions, it's probably easier to turn this number into a mix, from a mixed number into an improper. So that'd be 18 plus 1 would be 19. So this would be 19 over 2 divided by W is equal to 19 over 10. Okay. Yeah, so I would probably, I'm not gonna lie, I would switch these and create the new equation. So this is 19 over 19 halves is equal to 10 over W. And the reason is now I'm dividing by a fraction, which we know we could rewrite as multiplying. And so if I was doing that, what I really do is the 19s go away and I'm left with 2. So I now have 2 over 1 is equal to 10 over W. And if you just want to kind of scale this up, you can see that I'd scale it up by 5. So W would equal 5, and that'd be 5 feet. Let's see, our flag was placed on the moon, measured 5 by 3. Does this ratio form a proportion? I don't know. Well, what I can do is I can check it. I could say 19 over 10 is supposed to be 5 to 3. And then you can just check it. 19 times 3 turns out to be 57. And 10 times 5 turns out to be 55. Not sure why I wrote a number 1 in there. It's just 55. 55 and 50. Uh-oh, those are not equal. So this is not a true proportion. The flag placed on the moon was not proportionate to what apparently it's supposed to be. Pretty close, pretty darn close, but not exactly the same. All right. So there we go with those. Let's see here. Oh, these are fantastic. The proportion known as the constant of gravity, the gravitational force, is different on different planets because they have a different mass. So if you go to the moon, your weight is not as much. Looks like you weigh less. So what you could do is you can kind of create proportional reasoning on that and kind of see if I know here's my weight and here's how much I weigh on another planet, look at a different person, I could tell you how much they weigh on a different planet using that proportion, that constant of proportionality. And then we get to connections. So that wraps it up for this one. Keep in mind, you want your units to be the same. So don't put dollars per pound, and then in the next case, put pounds on top and dollars on the bottom, because those are not the same ratio. Make sure your ratios match, check your proportions, and you can use any of those tips that we learned in this chapter. So if you want to flip both of them over, you go right ahead. If you want to switch the middles out of one of them, you go right ahead. Whatever makes it more convenient. That's why those theorems are there, trying to make your life easier. All right, we'll see you soon. Off you go.